So here's a classic SUVAT equation question, or looking at a projectile that is moving purely under the acceleration of gravity. We've got a projectile, we're told that it's launched at an angle of 35 degrees with a speed of 25 meters per second, and we want to work out the time taken for the projectile to return to the ground. So instantly, before we even get started on this really, we should write in our horizontal and our vertical components. Our horizontal component is going to be 25 times cos of 35 degrees, and our vertical is going to be 25 sine of 35 degrees. So if we want to know the time it's going to take to get from its initial velocity of 25 meters per second and impacting the ground here, easiest way to do that is to say, all right, well, let's just model it in the vertical plane to begin with. Because I know I've got no acceleration in the horizontal, so I can just model this whole thing as if it's going up and coming back down again. The time taken to do that will be the same as for flying this complete flight here. I know that I have an initial vertical velocity, so my u is 25 times the sine of 35. And I know that if it hasn't lost any energy, it should impact with the same velocity there. But if I set u and v to be the same, I start to get a few little problems. So what I always like to do is say, all right, well, at the top of its flight here, it will instantaneously have a velocity of 0. And if it's not losing any energy, if air resistance is negligible, then the time that it takes to do this should be equal to the time that it takes to do this. So I can model this just in the vertical and work out the time it will take to get to v is equal to 0, the highest point in its flight. I know that my acceleration is minus g, which is minus 9.8. And then it just becomes a nice little modelling question. T is what I'm looking for. S I don't actually need. So I want to find out T when I have A, V and U. So I can use the equation V is equal to U plus A T. Sub in my values. 0 is equal to 25 times the sine of 35. And because g is acting in the opposite direction to my velocity going up, that becomes a minus 9.8 times t. So my 9.8t becomes equal to 25 sine of 35, because I can take my 9.8t over to this side by undoing what's been done there. It's been subtracted, so it becomes a plus on that side. So my t is just going to be equal to 25 times the sine of 35 all over 9.8, which gives us 1.463. That's the time to get up to its maximum height. So I just need to multiply that by 2 to get my total. And when I multiply my 1.463 by 2, I get 2.93. And that gives us answer C.